Good evening friends, I am Vchip and today we will see diode. Now diode, before that what exactly electronics? Now in electronics we see the control motion of the electron, obviously for the flow of what? For the flow of the current. Now we require the flow of current, we require the current. Now the conductivity of the metal is the much more as compared to the conductivity of the semiconductor, but still yes, we have mostly made a device by using the semiconductor rather than the metal. Reason behind that? Yes, anyone of you? Yeah, main reason behind that is we cannot control the direction of flow of current or the direction of flow of electron in the metal, but we can control the flow of electron, or we can say that electrons and hole in the semiconductor. In semiconductor, current will flow in only one direction, that is from anode to the cathode. Is it okay? In semiconductor means obviously in diode I am asking, particularly in diode I am asking here. Okay friends, now how we make the diode? We are taking one intrinsic semiconductor material. Then what exactly the semiconductor? The semiconductor is the element having 4 electrons in the outer shell. Is it okay? Now after that how we make the p-type material and the n-type material? If we have doped intrinsic semiconductor with the one side with the p-type and the one side with the n-type, then there is the formation of the p-n junction, where that form at that point where there is the metallurgically junction is formed, and that's called as a p-n junction diode. Is it okay? Now what exactly the p-type? What exactly this one p-type? And what exactly the n-type? P-type doping means the dope with the trivalent atom, and n-type doping with the dope with the pentavalent atom. Now trivalent atom means what? The outer shell having the 3 electron, and the pentavalent atom means what? The outer shell having the 5 electron. Is it okay? And they are surrounded by the millions of the semiconductor material. Suppose we are taking the silicon, then they are surrounded by the millions of the silicon. So they look like that. Yes, it is our first one. First one is our antimony. Yes, it is the pentavalent. So that here its outer 4 electron is the share with the surrounding 4 silicon atom, and the one extra electron is having, that is the ionically bound with what? With the antimony, and it will be the easily disattached. Similarly, that's the pentavalent, that means it donate the electron, is having the 5 electron in the outer shell, and it's required only 4 electron to become the stable, because whenever any atom becomes stable when it's having the 8 electron in the outer shell. Now antimony take 4 electron from the, or share its 4 electron with the surrounding 4 silicon atom, and it feel like or look like it's having the 8 electron in its outer shell. But antimony having the 5 electron, it share only the 4 electron with the surrounding silicon, 4 silicon, 1 extra electron. Now there is no need, because it's already having the 8 electron in its outer shell, so that electron is the ionically bond with the antimony, and it will be the easily disattached, because whenever that electron become disattached, then antimony become the stable. But in boron, in boron there are the 3 electron only. It is the trivalent. It is the 3 electron only in the in the outer shell, so that for the boron one stable, so it's required the 8 electron in the outer shell, but it's having only 3 electron of himself, and the 4 electron from the share 4 electron from the surrounding 4 silicon atoms. Still it's required 1 more electron, so that it's accept 1 electron from the others and become what? Become the stable. So that boron or the trivalent element or the material we called as the acceptor, because they accept the electron, and the pentavalent is called as a donor because they donate the electron. Also all of us know that electrically any material is neutral, or any element is neutral, or any atom is neutral. Okay, here what happened? See, because yes, number of electron is exactly equal to the number of the proton in that atom. But here what happened? Antimony lose one electron. That means now number of proton is the one more than the electron, because it's lose one electron. Now electron having the negative charge, so that it's lose one negative charge. So finally, yes, on the antimony there is the formation of positive charge, and the formation of positive charge on what? On the atom, so that it is the ion. It is the positive ions, generation of the positive ions. At the same time, boron accept the electron, so that number of electron become the one more than the number of protons, so that yes, is having now the negative charge on the boron, so that yes, boron is become the ion, and which get charge on that ion, that is the negative charge. Is it okay? Now yes, at that point what happened? Yes, number of holes are much greater nearer to the junction. Number of holes on the p side is much greater, and the number of electron on the n side is much greater, so that initially what happened, there will be the diffusion. Where diffusion is occurs when the there is the difference between the number of electrons or the number of holes. Now here number of holes are much more than compared to the n type, so that holes are moved from the p side to the n side, and electrons are moved from n side to p side. Now electron move from n side to p side, so that it's leave positive ion behind, and yes, p type leave the negative ion behind. And this ion, what exactly they do? Yes, they oppose the further flow of the current. But anyhow, here how current will flow? Electron flow from n to p, and the hole will flow from p to n, so that possibility of the current flow, yes, current flow in the direction of the flow of the holes, and in the opposite direction the flow of the electrons, so that always current flow from p to n only. Also yes, in our element, how we can come to know which one is the p type and which one is the n type? Then always keep in mind that line is toward the n type, or that's line toward the cathode. Is it okay? So that just by looking element, we can say that yes, which terminal is the anode and which terminal is the cathode. N type or the negative terminal is called as a cathode, and the p type or the positive element is the terminal is called as a anode. Is it okay, friends? Okay, after that, diode. In that, how can we suppose we forget which one is the anode and which one is the cathode. Actually, in my third year, my lecturer asked one question. Just ask me which one is the anode and cathode, and you didn't believe I can't answer out at that time. I couldn't answer out which one is the anode and which one is the cathode in that. So that I just explain here one simple method to remember which one is the anode and which one is the cathode. Then just what exactly I am doing here. Yes, I'm just what exactly I am doing. Here I am extending, suppose this two terminal like that. Okay. And also I am extend that one like that. Now that line I will extend that side also, and that's line here also. Now just look, suppose we look here, then just look what exactly it's look like. It's look like the A, that portion, how exactly that portion is look like. It's the A, so that is the anode. And now just look what exactly is look like. It's look like the K, so that is the cathode. I think now you never forget which one is the anode and which one is the cathode. Now in the unbiased diode, what exactly happened? Initially the number of the electrons on the n side is much more, and the number of the holes on the p side is much more, so that is lose the electron and form what? Form the positive ions on the n side, and is accept the electron, so that there is the formation of the negative ion on the p side. Because of the formation of these ions, what happened here? Now it is what? Here there is no any mobile charge. Mobile charge, how many charge we having? We having the 4 type of charge. Yes, one is the electron, hole, after that positive ion and the negative ion. Now here, we don't having any mobile charge, we having only the ions. Is it okay? So that they are not support to the flow of current, because who support to the flow of current? Yes, flow of current is because of the flow of the charge. Is it okay? Now there are the four charge. I already asked that positive ion, negative ion, after that electron and the hole, but ion cannot be moved in solid. Is it possible ion become move? Ion means what? Ion means the atoms. Is it okay? If atom become move, then it cannot be the solid. It may be either, yes, it may be either liquid or the gas, but not a solid, because a solid atom never move. Is it okay? So that who will support to the flow of current? Only electrons and the holes. But here, yes, there is only the ions are remaining. Is it okay? And they did not support to the flow of current at all, and also they oppose to the further move of the electron from the n side to p side, and the move of the hole from the p side to n side. Why it is? Because of this ion, there is the formation of the electric field. Electric field is formed from where to where? From the positive to the negative charge. Is it okay? Now electric field is the obviously from n to p side. Now here there is the force on that hole. Yes, that's the hole. On that hole there is the two forces. One is the force due to that electric generation of the electric field, and the another force is because of the diffusion force. Why diffusion force? Because at that point, yes, on this side number of the holes are much greater, and on this side number of the holes are much less, so that holes always move from higher density to the lower density. Is it okay? Same for the electron also. But what happened here? Yes, that electric field opposed to the further movement of the, or the further diffusion of what? Further diffusion of the holes. And because of that, what happened? Because of that, yes, current is not flow when the diode is unbiased. Is it okay? And here on the junction there is the formation of some voltage because of that electric field. That's called as our, yes, junction voltage, or the built-in voltage that we will ask. First, if we have to flow the electron from the n to p and the hole from the p to n, then first of all, what exactly we have to do? We have to collapse that depletion region. Why it's called as depletion region? Because it's deplete the charge carrier, any mobile charge carrier. So it's also called as a depletion region. Okay friends, so that, yes, for that we have to apply what? And because of that, what happened here? Initially what happened? The hole can easily move from n to p and the electron from p to n, but because of that there is the formation of the ions, and that ion form the depletion layer, and because of that our, yes, our band gap is bent. Because of that electric field, our band gap become bent. Now electron, yes, having the barrier, or they have to jump for the move from the n side to p side, and obviously electron always prefer the low energy level, and the hole always prefer the higher energy level, so that all the electron in the n side, they prefer this level only, and they don't like to go to the higher level, or they require some energy to move to the higher level. And the same thing for the hole. Hole always prefer the, yes, high energy level, so they never prefer to the low energy level. They require some energy to move from the, or jump from this point to this point. Then what happens if we apply the forward bias? So yes, forward bias, electric field due to the forward bias and the electric field due to the depletion field, they are the opposed to each other, and that forward bias electric field will collapse the electric field that generated due to the depletion region. And because of that, what happened? Yes, our depletion width decrease, and that barrier width also, or that depth is also decreased. Now electrons are easily jump from this one, because that height is decreased, and because of that, what happened? Yes, electron move from n to p and the hole move from p to n. But if we apply the reverse bias, in that case also keep in mind about the Fermi energy level. If we look about the Fermi energy level, then it's moved toward what? Toward the, goes upward toward the negative terminal. Here is the negative terminal, is go upward toward the negative terminal, and downward toward the what? Positive terminal. Now suppose we apply opposite bias, means reverse bias. That is the, already here what exactly? Number of the depletion region is formed, and the we are apply, yes, electric field also, that support to what? That supports to the, yes, our field that generated due to the depletion region. So that what happened? That depletion width is yes, increase in that case, and obviously now electron cannot move to or jump to that point. Is it okay? Now current can flow only because of the flow of the minority charge carrier, because it supports the flow of minority charge carrier. Okay friends, thank you very much.